Today, I'd like to present our work on improving model search through structured tables. The way we build AI systems has changed dramatically. Instead of training models from scratch, today's workflow usually starts by selecting a foundation model from public model lake repositories and then adapting it to downstream tasks. As a result, model selection has become a critical first step. Choosing the wrong base model can lead to unnecessary fine-tuning cost and additional trial and error before finding a suitable model. How do users search for models today? Most existing model search systems match a user's natural language query against model cards using keyword or semantic retrieval. However, this has limitations. First, users often cannot fully express their intent. They may not know the exact benchmark names or technical keywords. Secondly, model cards are often noisy and inconsistent. Some are carefully maintained, while others are incomplete or copied from templates. As a result, current methods retrieve models based on long documents that mix useful information with irrelevant content. Instead of searching the entire model card, we look at the tables. We observed that tables contains the most informative evidence about a model, including its evaluation results, experimental settings, configurations of datasets, and examples. More importantly, models from related models often share very similar structures. For example, these three tables come from different pre-trained language models. Although they describe different models, they evaluate similar benchmarks and compare similar baselines, resulting in highly similar table structures. This observation inspired us to ask a simple question. Can we search tables instead of searching model cards? Starting from one anchor model, we retrieve structurally related tables, which naturally lead to a broader set of relevant models. Compared with traditional search, these retrieved models are not simply duplicates, but provide more diverse alternatives while remaining highly relevant. We integrate table discovery into existing model search pipelines. Our first pipeline starts from an anchor model retrieved by baseline search system. We extract its benchmark tables and searched our indexed model table corpus to discover structurally related tables. These tables introduce additional candidate models before the final re-ranking stage. We also study a second variant that directly retrieves an anchor table from the user query, while keeping the remaining pipeline unchanged. Our goal is to retrieve not only relevant models, but also diverse ones. To evaluate this objectively, we borrow the concept of nuggets from information retrieval. A nugget represents one atomic fact that is relevant to a user query. If one retrieval method covers more nuggets under the same retrieval budget, it provides richer information and therefore higher diversity. Next, we define what a nugget means in model search. Each model nugget consists of a task, a dataset, a metric, and a reported numerical result extracted from benchmark tables. We further include two Hugging Face-specific attributes, the base model and the model variant, such as fine-tune, quantized, adapt, or merged models. For evaluation queries, we adapt an existing paper recommendation benchmark by replacing research paper keywords with keyword AI models. This provides realistic model search queries while preserving the original evaluation protocol. We compare 9 retrieval methods in our experiments. The baselines include sparse, dense, and hybrid retrieval. Our framework contains 2 retrieval pipelines, card anchor and table anchor, each combined with 3 table discovery operators, keyword search, joinable search, and uniable search. The figure reports nugget count distributions. Overall, structured retrieval consistently discovers more nuggets than semantic retrieval baselines. Among all methods, the table anchor pipeline achieves the strongest nugget coverage. It also consistently outperforms the corresponding card anchor variants, suggesting that choosing the anchor table is a key factor for improving diversity in structured table model discovery. We further compare how often each method ranks first across different queries. For K across the top 1, top 3, top 5, and top 10 settings, table anchor methods consistently achieve the largest number of first-place rankings. Card anchor remains competitive but gradually falls behind as the retrieval budget increases. In contrast, semantic retrieval baselines rarely rank first. A similar trend can also be observed for second place and third place rankings. These results further demonstrate that table anchor produces stronger and more consistent retrieval quality across different queries. Here is one representative example. The retrieved benchmark tables share the same evaluation structure, making the model directly comparable. Although they follow the same table schema, they correspond to different models with complementary strengths. This demonstrates that table discovery retrieves diverse but still comparable models for users to explore. On the previous expert-based annotation for model recommendation is that the model ecosystem evolves rapidly. As new models are continuously released, manually annotated nuggets quickly become outdated. In the future, we plan to adapt our strategies to automatically extract nuggets from benchmark tables so that the benchmark can continuously evolve together with a growing model repository. Finally, we developed an interactive system to demonstrate our framework. The interface presents retrieved models together with their nugget scores and integrated benchmark tables extracted from the model cards. This allows users not only to retrieve models, but also to directly compare their benchmark evidence through a unified interface. Thank you very much for listening.